welcome everybody to all of you, wherever you may be tuning in from globally. I hope you find the next little while interesting and that you learn something that might be, if not just of interest, but might actually help you yourself with your running, or if you're working with athletes, that's maybe something you'd be able to pass on to the athletes that you work with. But just as by way of introduction of myself, since we don't have a chair for the meeting, I'll do the chairing as well then, so that you buy into what I'm saying and don't maybe think that I'm just some professor sitting somewhere and what I know about running. I've been running for something like 55 years, so I do know a little bit about running. I've done 10 Comrades marathons, and those of you who are into the ultra marathon will probably be aware that this is one of the most prestigious ultra marathons in the world, and I'll be speaking quite a bit about pacing in that race in the next little while, as well as the other big ultra marathon that we have here, the Two Oceans. Marathon time is on the PB days is a 2:22, and I've run just under 6 hours for that Comrades marathon. In terms of research, I've been involved in running research for 40 years as an academic, looking at various things from nutrition to training to recovery and so on. And as almost like a carryover from that, it's been interesting as well as something enjoyable to me to be able to work with athletes. So applying the theory and the science and so on to the real world athletes. In that respect, I was co-leader of the sub-2-hour marathon project and also leader of the nutritional aspects of that project. When the next speaker is about to speak later on, I will do a little bit of introduction for her as well. So kicking off my presentation, which is looking at pacing patterns in ultra marathons, I did mention in my introduction there that I'll be focusing quite a bit on two of the important ultras in South Africa, namely the Comrades Marathon and the Two Oceans Marathon. And this slide that I've got up here, the picture shows part of the route of the Two Oceans Marathon, where my cursor is over here, where you can see this cleft in the mountainside. That's called Chapman's Peak. And in the Two Oceans Marathon, that is one of the significant hills that the runners have to negotiate, as well as a second one further into the race. So the question is, how do people pace in these ultra marathons? A lot of work has been done in shorter distance events, and especially so in the marathon. And what this slide shows as background, if we have percentage of average running velocity where my cursor is now, and this is the percentage of the race distance that has been completed, you have three typically described ways that pacing might work. The one is the so-called U-shaped, over here, shown like that. And then we have the reverse J, where my cursor is now, and then the J-shaped, where I'm now pointing. Now, those are maybe theoretical curves. Certainly in recent times, the standard marathon has turned around a little bit and is showing changes in the way that the pattern of pacing takes place with significantly faster second halves. Yes, the J-shaped curve does show an increase in pace here, but it's very pictorial in that in real world, the top people will be running at a fast pace, and then in the second half of the race they kick up a gear and just run even faster. So it doesn't quite follow this increasing pace that is depicted in this curve over here. Nevertheless, if that has been done in the marathon and so on, in terms of analyzing pacing patterns, very little has been done in the ultra. And some work has been done on trail running, particularly some of the better known off-road races in the US have been quite well studied. But mostly, you could consider that in the ultra world, relatively little has been done looking at pacing. So in terms of the Comrades Marathon, which is a 90-kilometer ultra marathon between two South African cities, Durban and Pietermaritzburg, the race, because of the nature of running 1 year from Durban to Pietermaritzburg, termed the up run, and the next year would alternate down. So it goes from Pietermaritzburg down, particularly, as you'll see in a profile in a moment, into Durban. Even though it's the same route, they're very different because the one is predominantly up in nature and the other one is predominantly down in nature, although both have lots of up and down hills, as you will see. So the question is, if you are one of the race winners, this is a picture of Costa when she broke the record a couple of years back for the 90K race. She averaged something like 4 minutes per kilometer, which is about 6.5 minutes per mile. So pretty fast running. How does she and others like her pace the race compared to people who are just finishing the race and finishing in the last hour, somewhere between 11 hours or 12 hours, running at half the speed that the top people are running? Now, I showed you the picture of the race winner here, Costa. What I'm about to tell you might not be applicable exactly to the very elite, fastest runners in the field, but certainly, as you'll see, it certainly is applicable to, if we just label it as fast runners. So this is the route profile for the so-called up Comrades, starting over here on the left in Durban and finishing 90 kilometers later in Pietermaritzburg. And it's quite clear that the beginnings of the course over here is predominantly uphill to around about the 38-kilometer mark. Lots and lots of climbing, as you can see, although there are some significant downhills as well. And then you get to a relatively, and I use the word carefully, relatively flat section over here, climbing to the steepest part of the race over here at Omlaas Road, and then some significant downhill running. A little blip over here when you're tired, you certainly feel that, with poly shorts, and then a predominantly down run into the finish. Now, when we analyzed the pacing in this race, we were at the mercy of the race organizers in terms of where the timing mats were placed. So that was where these arrows are. So at 20 Ks, around about 48 Ks, 60 Ks, just after 70 kilometers, and then with about 8 kilometers to go over here. And this one's just at the finish. So they're not equally spaced out, but that doesn't matter. We're looking at the running speed between each of these segments, as you'll see. Now, if we just plot the pure running speed over the race, we'll get a picture that looks somewhat like this. Now, over here, we've got the speed in kilometers per hour. My apologies to those of you who kilometers per hour mean little and we work in miles. I should probably put on miles per hour pacing here as well. Sorry about that. And then we divide them into various groups over here with these runners being the fastest group in the race, and then the next fastest, the next fastest, and the next fastest. So this represents about the first 1.5 hours of finishes, and then the next 1.5 hours, and so on. And the first striking thing, if you look at this globally, is that overall, the picture looks very similar, doesn't it? So if you look at the fastest runners over here, and you look at the next fastest and the next fastest and the slowest over here, overall, if you look at that, the pattern looks pretty similar. Now, when I first saw that, I was actually quite surprised by that because I was expecting to some degree that the faster runners might show a difference in change of speed compared to these runners here in terms of overall speed through the race. By the way, these are the different segments, the timing segments along the bottom that we have. And overall, this represents about 20,000 runners that is analyzed. Now, if we express these data differently, instead of looking at it in absolute terms of speed, but we relate these to a percentage of the average speed for the race, the picture looks somewhat different. And that's what we have over here. So this is the percentage of race speed. So if we take somebody who runs the race in hours, 8 hours, say, then the average speed is X, and then we express each segment 1, segment 2, segment 3, and so on. We express each one of those as a percentage of the overall race speed. And that's important just to get your head around that is the overall race speed, because the next slide is going to be looking at relative to each segment and not the overall speed. So if we look at this over here, the most interesting part of this graph lies right here in terms of the percentage of overall speed at which the first segment is run. Now, these runners here are the slowest runners, and these here are the group that are the fastest quartile in the field. But what is interesting is, although these were going to provide the race winners and the top 25% of the finishers, look at these people here. These people are substantially slower, but they're starting relative to their overall race speed, they're starting much faster than the people who are eventually going to be in the top 25% amongst the finishers. This group here is particularly interesting, I think, because they're the second fastest group ultimately. And I think what might be happening is that these people overestimate their abilities and start way too fast. So they overcook it a little bit here in the first segment compared to the people who really know what they're doing, I suppose. And that is the people who are going to make up the top finishers in the race. And then the pattern that follows is fairly similar throughout. Bearing in mind that I showed you the profile, there are some significant hills. And so some of these changes here are certainly related to the nature of the course, uphills and downhills and so on. But nevertheless, what is striking is that the race pace is getting slower per segment, even though there are some sections where the profile is actually quite quick. So for instance, over here, this is a fairly flat part of the race, but they're actually still slowing down. And then finally over here, in the last segment, all of the runners are speeding up. Now, partly that would be what has been termed the end spurt traditionally, that as you know, the finish is getting quite close. You start running faster because you know the end is close by. But in this particular race, what is also noteworthy is that the last 8 kilometers of the up comrades, even though it's called up, the last 8 kilometers contains a lot of downhill running. So you can speed up if your legs aren't too bad at that point. Now, the next slide shows things a little bit differently. Instead of expressing it as a percentage of the overall race pace, this slide shows pace expressed as a percentage of the first segment. So over here, what we see is, again, I'll center in on this group over here. These are the people that ultimately were going to be the second fastest group in the race. But they're not running quite as fast here as just about everybody else in the race. And probably that is because they overdid it in the first segment over here. So they've already slowed down significantly in the second segment, which kind of continues throughout. And an interesting take-home thought here is that if these people started a little bit easier and didn't go quite as fast, if they started maybe over here, then maybe they would have been able to better maintain their speed and not drop off quite as low as they do over here. Nevertheless, they still are the second fastest group because of their overall pace, the very first slide that I showed you. I went through that in some detail to explaining what the makeup of the slides was. So the next couple of slides are going to be done a little bit quicker, and I'm just going to center on the patterns that are involved. So this was the male runners in the up comrades. What about the female runners? Sorry, what about the down race? So this is the reverse. So it starts off fairly flat over here. There's quite a big climb over here, quite a nasty part of the race. And then there's undulations all along the way until you get to this point here at about 65 Ks into the race, where it really just becomes a lot of downhill running. And that might seem ideal, but it really is kind of leg destroying. And you can really fall apart, so to speak, in running terms in the last bit of this race, because you have incredibly sore legs as a result of these long downhills. This downhill section here, for instance, you get to this part here, Kai's Hill, and as a person who's run this race, I can tell you your legs are just finished. So what about the pacing here? Well, once again, this is the overall pace of the race. And what we see, if you look at it in a global way, the pacing of the fastest group, the second fastest group, the next fastest, and the slowest group mirror each other just about. They all look very similar. And if we look at the percentage, we see very much the same of what was pointed out in that first slide, that you have these people running the first segment at a fairly low percentage, 105 if you call that low, but low compared to up here at 110%. And once again, if you look at it, it mirrors what happens in the up race. Here are your fastest runners, the orange line, and yet they are starting at a slower pace from a percentage point of view than these people here, who are ultimately going to be the second fastest group in the race. And then the rest of the pattern remains much the same. And then interestingly, the pace is still dropping away here despite the course getting faster, most like downhill, and most likely it is, of course, everybody has tired legs and sore legs at that point. If we look at it as a percentage of the first segment, it's following the same order here as I did in that first slide. Once again, the fastest group are not going particularly fast compared to some of these lesser groups over here. So these people have sped up quite a bit, even though they are destined to, they are the slowest runners. It's early days in the race, and they, by the looks of it here, are perhaps running too fast and would be better off running somewhere down here at a lesser percentage than what they are actually doing. But once again, if you look at it in a global sense, the pattern of the runners looks very similar, other than here in the beginning of the race. If we look at the female runners in the down race, so we just looked at the males again. How does it differ in the females? Not much really. Again, in the overall sense, the patterns of speed throughout the race are similar. Again, I'll just remind you, some of this apparent slowing down and speeding up is due to the terrain and not physiological changes. And if we look at the percentage of mean race pace, a similar pattern emerges. The orange line, once again, is our mean for the entire race. And here are the slower runners. If anything, what looks like might be happening here is that the female runners might be starting off more conservatively in the beginning of the race than their male counterparts in the down race. And this is something that comes up when people have looked at pacing in the standard marathon. The goals seem to perhaps not start off quite as overly ambitiously as do the guys. And again, if you look at the pace of the first segment percentage-wise, you'll see the ultimate top people are taking it fairly conservatively here in the first bit of the race, whereas the people who are slower are actually paradoxically working harder relative to their overall race pace. This is the Two Oceans Marathon. This is a 56 kilometer race, or 35-mile race, also a very popular ultra marathon in South Africa. It has a bit of a different profile in terms of the first half shown here where my cursor is now. The first 28 Ks is very, very flat. And then all the hills come after that. Here's the Chapman's Peak that I showed you in the opening photograph. You descend after Chapman's Peak and then climb again up something called Constantia Neck. Very nasty, steep climb over here. And then there's a series of downhills as you run in towards the finish. So what about pacing in the Two Oceans? What do we find over there? Well, once again, if we look at the overall pace in terms of kilometers per hour, the speed at which the runners are running, if you look at this globally and holistically, these all look like mirror images just about, with the fastest runners at the top here, and these are the slowest runners here. In this particular race, the Oceans compared to the Comrades, we divided the finishers up into many more groups shown over here than we did with the Comrades. So there are a total of 7 different groups, categories of finishers that we looked at. So it's a lot more defined, if you like. So this is the overall pace for the female runners. And if we look at what happens when we look at the percentage of how they start the race in terms of percentage of their overall finishing time, this is quite interesting. Because over here, this orange line again is the group that is going to eventually be the fastest runners in the race. And yet look at how this group behaves. They are the slowest runners in the race. They're going to ultimately run the slowest times. And yet from a percentage point of view, they are running a lot faster than the fastest group in the race. And this is despite being the female finishers, because I postulated in the previous slide with the Comrades that perhaps the girls pace themselves a bit better than the guys, but that's certainly not happening here in the Oceans. And I think that might be that the flat first half maybe gives a false sense of security, and you feel great, you feel you can just run away with it, so to speak, and people overcook it over here and go too fast and then slow down significantly. So if you look at the slope of this line, it comes down staggeringly to the next segment, whereas the group that contains the fastest runners do not slow down nearly as much if you look at the slopes of those curves. And this is the pacing patterns relative to the first segment again. So here the fastest and here the slowest. The people who started so fast over here are now already running much, much slower in the second segment of the race, which in this case contains Chapman's Peak that I mentioned. So again, I think these people are paying the price here for starting way too fast. They would have been probably better off if they started a little bit slower and been able to run a little bit faster here in the second and third and final segments. So all the groups show the same pattern. You can see there's mirror images here, no difference really between the different groups in terms of the overall pattern of the pacing. If we look at the male runners, again, looking now at the overall pace, and you're now familiar, I'm sure, with what we are seeing here, that there are mirror images of the runners from the fastest down through to the slowest over here. They're just like tram lines in terms of what they look like. And similar to the females, the males show the same thing happening, that over here, the group that contains the fastest runners that are going to, the fastest finishers are starting by running the first segment of the race at a lower percentage of their average race pace than what these runners here are doing. And again, as you're now becoming familiar with the pattern holds, it looks similar throughout. This over here, this increase in speed, once again, it could be related partly to the established end spurt that I mentioned, but of course, the finish here is a particularly fast finish in terms of the course profile. So two things are coming together here to make for a very fast finish, increase in speed. And we see exactly the same thing in the male. So I'm not going to go into any detail. I just wanted you to see that you can't distinguish the males from the females over here in terms of the pacing patterns. I just want to quickly, before I finish, look at some other races. This looks rather busy, but I'm going to take you through it quickly, but nevertheless, it'll all be a lot easier to see than what looks at first glance. This on the panel on the left here is a 160K ultra marathon, a 100-mile race in Malaysia. And this is a 100K 60-mile race also in the same course in Malaysia. And the reason I'm showing this is because I was involved in the analysis, but also this is now a much flatter course than what I've shown you up until now, but it has a different set of things that make it complicated, and that is it's very hot and very humid. So if we look over here in the 100-miler, if we look at the fastest, the middle group, and the slowest group, look at the patterns. It goes down, stabilizes a little bit, and then maybe a bit of a kick up over here, goes down, stabilizes, a little bit kick up over here, goes down, stabilizes, and a bit of a kick up. This is the 60-miler, same group, fastest, middle fastest, and the slowest runners, and slow down, and then maybe a bit of a kick up, slow down, kick up, slow down, kick up. So what have we got? It doesn't matter if you're the fastest or the slowest, you're showing the same patterns. It doesn't matter if it's over here on the left, the 100-miler, or over here on the right, the 60-mile race, the patterns all look identical. And if you distill it down to look at the trend lines, and once again, we're looking at the percentage of the starting pace, what do we see? The trend line there, and there, and there, that is for the fastest, the mid, and the slowest. For the 100-miler, looks exactly the same as for the 100K, over there, and over there. Can't really distinguish between them. The same patterns are emerging. And if we simplify it down to this is the percentage of the initial speed of 100 is obviously 100% would be what you're starting at. Line A is the fastest, line B is the second middle group, and C is the slowest group of runners that we analyze. And we get exactly the same pattern over here. So everybody is slowing down with the top runners a little bit less so than the mid runners, and a little bit less so than the slowest runners in the field. So what does this mean from a time prediction or management point of view? Well, let's just go back to our Two Oceans marathon. There are predictable relationships between the marathon time and the time that you're going to run in an ultra. This shows the relationship between marathon time and the oceans time. I have a similar graph, for instance, that I've got that I use for the comrades, up run, down run, and it works. And if anybody is interested, you can make your own graphs for any race you like by getting hold of some data and doing the analysis work. But what this means is that if, for instance, you have a 3.5-hour marathon, if you want to be scientific about it, that would mean that realistically, you should expect to be able to run a 5-hour Two Oceans marathon. The Two Oceans being 35 miles to 56 kilometers, remember. So based on that, you can then work out what pace you should be running your ultra at, which brings me to the final slide, which is applying what I've shown you in terms of a practical takeaway message in what these patterns of pacing says. So the first point is that slowing down is inevitable and predictable, and you can actually write, if you like, mathematical lines for that slowdown. So set an appropriate goal time that you want to run. So if you're running the Two Oceans 56K or something other race somewhere in the world ultra, don't just go into the race and hope for the best. Use some other race to predict what you can run in the race that you're about to embark on, and then work out over here the average pace that you should be running for that, and maybe make some allowances if it's a hilly race for time that you're going to lose and gain as you run up and down the hills. Because we know the predictable slowdown, to best be able to run your average pace, you need to start off a little bit faster than the goal pace in order to allow a slowdown as the race progresses, so that you ultimately will end up with your goal time. However, having said that, don't start too fast. Starting too fast, as I showed you with those pacing patterns, especially in the Two Oceans, is a common problem, and runners would probably be far better off if they started at a more modest pace and allowed some better pacing to occur. All right, so thank you very much. And with that, I will finish off. And if anybody has any questions, you can unmute yourself and I will try and answer for you.
Thank you very much.
Before we move on to the next speaker.
Thank you very much, Andrew. Very interesting. I got two questions, actually. Did you, within your graphs or your calculations, did you take every runner into calculation, or how big was the group of the beginners or the slow runners, the fast runners?
I'll answer that first. So that was if we were looking at the male runners, it was all the male runners that started and finished the race, and likewise, if it was the female analyses, it was all the females that started and finished the race. For the comrades, that was about 20,000, 22,000 runners for the males, and a little bit less for the females, and a little bit less than that for the Two Oceans analysis.
Yeah, that's very interesting, because we must have a good program that does that, because I don't think you do it by hand, do you?
No. No, it was entered into a program, yeah.
Yeah. The second question is, what surprised me quite a bit was that even the slower runners, even though you demonstrated that they usually start, or a lot of them start too fast. Yes. I would think they would slow down much more than they did, and that the curve would, because of that, not be similar to the other runners. Can you explain that? Because usually, like when you overdo, you usually cannot keep it up, and if you are an experienced runner, you don't drop that fast, and you usually in the end can speed up much more than the others. I would have thought, but you proved different.
Yeah. No, maybe I didn't explain that quite well enough. It actually shows, if I'm understanding your question correctly, what you're describing is indeed what happened, Matt. The slowest runners in the field started relative to their overall pace. They started very fast, but they did drop off substantially after that.
Yeah, but the gray, like if you the comparison, all four groups, like
Yes.
they had the same kind of degree, the same average of decrease and increase in the end again. It didn't differ. I would have expected the curve to be different.
I would have expected it too. So that was quite a surprise. It is driven a little bit by the nature of the course. So fastest and slowest runners all get exposed to the same hill, so they'll slow down and they'll speed up. But yes, certainly that was a little bit surprising to me as well.
Yeah, thank you. Are there any other questions?
Right. Okay. Well, let me introduce the next speaker, who is Devon Costa. She's a PhD researcher at the University of Cape Town, in the Department of Human Biology, in the research center called HPALS, and she previously has researched the effects of ketones on performance when she was doing her master's degree. For her PhD research, she is looking at the effect or the possible effect of medium chain triglycerides and how it might influence performance. And she's embedded with the Sports Science Institute of South Africa as a research consultant. So over to you, Devon.
Cool, thank you so much, Andrew. Hi, everyone. Yes, so I'm going to be speaking about medium chain triglycerides and their potential to be the next silver bullet for the ultra marathon runner. Sorry, just give me 2 seconds. Okay, so these are some of the points that I am going to be covering. I'm going to start with the current recommendations for ultra endurance running. I am also going to speak about our energy metabolism just very shortly. I'm then going to move on to the potential of MCT as well as the combination of carbohydrates and MCTs together. I'm also going to speak about various methods of increasing fat oxidation rates, as well as some considerations that we should take into account when discussing MCTs. So ultra-endurance running currently has recommendations that are very similar to that of marathon running. And this is due to the fact that they both use very similar energy metabolisms. It's also because there's actually been very few studies that have been conducted in ultra-endurance athletes. And it's important to remember that as I go through this presentation, because a lot of the recommendations that we currently have for ultra running has come from studies done on half marathon runners, marathon runners, and predominantly cyclists. So just something to keep in mind. The current recommendation for ultra runners are to carbohydrate load 2 days prior to a race by ingesting 10 grams per kg that they weigh per day of carbohydrates. And this is in hopes of increasing muscle glycogen stores. Research shows that having high levels of muscle glycogen going into a race can extend the time that a person reaches fatigue. In addition, runners are recommended to ingest 60 to 90 grams of carbohydrates per hour whilst running in order to maintain steady blood glucose concentrations. Again, research has shown that the ability to maintain steady blood glucose throughout a race will help extend the time to fatigue. But despite these recommendations, most ultra runners report that they battle to get over 30 grams of carbohydrates per hour. Additional challenges that we often see in ultra running is a very high calorie expenditure. If we look at a runner who is taking part in a 24-hour continuous type run, they could burn up to 18,000 calories in a race. This is often paired with very low calorie consumption, which makes sense if we consider the fact that they are only supplementing with carbohydrates. They're only getting 4 calories of energy per gram of carbs. These two challenges together results in an inadequate calorie consumption as well as an inadequate carbohydrate consumption. And this just exacerbates the depletion of muscle glycogen, particularly during high intensity bouts. Muscle glycogen depletion is very common in any sort of endurance activity, but the fact that these runners are having, or that most ultra runners are experiencing low calorie consumption and not enough carbohydrate consumption, their muscle glycogen is depleted a lot sooner, resulting in them experiencing fatigue earlier on in the race. Before I move on to MCTs, it's important that I just a little bit on our exercise metabolism. So we have two different energy systems that we make use of when we are exercising. We have the anaerobic or oxygen independent system, and then we have the aerobic energy system. And the use of these energy systems is determined by duration and intensity. If we look at high intensity exercise or short duration intensity exercise, we predominantly use our anaerobic glycolysis. This is the process where we break down our blood glucose from our liver and our muscle glycogen in order to produce ATP. If we look at longer duration events, this is where we will use our aerobic metabolism. Whether it's short duration or long duration, any sort of high intensity bout is going to break down our carbohydrates, depleting our muscle glycogen. It's the low to moderate type endurance exercise where we predominantly use our fats. However, during long duration events where we should see an increase in fat metabolism, or where we do see an increase in fat metabolism, muscle glycogen is still depleted, particularly during high intensity scenarios, which are very common in any sort of race type situation. Despite runners being able to meet fueling strategies that I mentioned earlier, muscle glycogen is still depleted and fatigue still sets in. In theory, if we were able to spare muscle glycogen, or at least reduce the rates at which muscle glycogen was depleted, we could reduce the feelings of fatigue, or runners would be able to extend their time to perform without experiencing fatigue. And this could potentially be done by increasing our fat metabolism. There's various ways to increase fat metabolism, and this is either through dietary changes or supplementation. Theoretically, an ultra runner with a high fat oxidation rate of above 1.2 grams per minute could sustain roughly 450 calories per hour of energy just from fat oxidation alone. This is extremely beneficial when running in prolonged events of above 10 hours. And even more so during low to moderate events, because this is where we see an increase in our fat metabolism naturally. Low intensity exercise is about 5 to 6 kilometers per hour, or 45% of a runner's VO2 max. And a moderate intensity would be about 8 to 12 kilometers per hour, which would equate to about 50 to 70% of VO2 max. In order to induce any sort of increases in fat metabolism, it usually takes about 2 to 4 weeks of following a high fat diet. It is runner dependent, and there are other strategies to increase fat metabolism. For runners who are following a high fat diet, they can test their blood BHB, or beta hydroxybutyrate, otherwise known as a ketone in their blood. Research shows that when you have a resting ketone concentration of 4 millimoles per liter, you are capable of metabolizing more fat than if you weren't fat adapted. But for someone who doesn't want to follow a diet, there are additional strategies to increase fat metabolism, and that is through supplementation, particularly through the supplementation of medium chain triglycerides, or MCTs. I just want to speak a little bit about the metabolism of MCT. So if we look at our long chain fatty acids, these are oxidized at a much slower rate than carbohydrates, and their absorption is ultimately determined by the availability of the muscle cell. These long chain fatty acids require the carnitine shuttle to enter the muscle cell, and this is what causes their very slow absorption rates. This is the reason why the body favors carbohydrates during high intensity exercise. But MCTs do not require the carnitine shuttle to enter the muscle cell, and they are rapidly absorbed. In addition, they're absorbed directly into the portal vein of the liver. This means that they have the same rapid absorption rate as carbohydrates and could potentially be utilized at the same rate as carbohydrates. If looking at this study here, we can see the effectiveness of medium-chain triglycerides in comparison to long-chain triglycerides. So this was conducted in a group of cyclists who were cycling at 80% of their VO2 max until exhaustion. This was after they cycled for 40 minutes at 50% of their VO2 max. Half the group was asked to ingest medium-chain triglycerides, while the other half was asked to ingest long-chain triglycerides. We can see that the group who ingested medium-chain triglycerides were able to cycle for longer before they became exhausted than the group who were ingesting LCTs or long-chain triglycerides. MCTs are especially well catered for ultra running due to the moderate intensity at which it takes place. When supplementing with MCTs in the research, we can see an increase in fat oxidation as well as a reduction in carbohydrate oxidation, and this indicates a potential sparing of muscle glycogen. In addition, we commonly see reduced lactate concentrations. And what this means is that there's a lower reliance on glycolysis. Glycolysis is the process where our blood glucose is broken down into pyruvates to produce ATP, which is the energy molecule that we need. If we see a reduced lactate concentration, that means that less glycolysis is being used and less carbohydrates are being used, potentially further sparing muscle glycogen. This often relates to an increase in performance, particularly sprint time. So what happens when we compare medium-chain triglycerides or MCTs to carbohydrates? This was a study conducted during 270 minutes of submaximal exercise, where one group was asked to ingest carbohydrates and the other MCTs. We see in the MCT group that they had a higher fat oxidation rate. Sorry, I'm just getting my pointer. So here we can see that the MCT group had a higher fat oxidation rate. They also had a lower carbohydrate oxidation rate. We saw the same things in another study, which was conducted in a similar race type scenario, except this one was done during 270 minutes of submaximal exercise. And the next that I'm speaking about was done with 2 hours of submaximal exercise, followed by a high intensity 40-kilometer time trial. We saw the same changes in increased fat oxidation in the MCT group and decreased fat oxidation in the MCT group. We also saw this lactate concentration trend, which is very common in studies testing MCT. The MCT group was able to maintain a relatively steady lactate concentration, even once they went into the high intensity 40-kilometer time trial after 120 minutes. The carbohydrate group, on the other hand, saw a significant increase in lactate concentrations going up to 4 millimoles per liter very shortly into their 40-kilometer time trial. This would indicate a large reliance on glycolysis for energy or carbohydrates for energy. Did this result in improved exercise performance? Unfortunately not. The carbohydrate group still outperformed the MCT group. And one of the reasons that could have been due to was that the MCT group was unable to sustain steady plasma glucose concentrations. I mentioned earlier that research has shown that maintaining steady plasma glucose concentrations is a way to extend the time to fatigue, and this was clearly seen in this study. The MCT participants were not able to perform at the same rates of the carbohydrate participants. We can see that the carbohydrate participants were able to maintain steady blood glucose concentrations of above 5.5 millimoles per liter. But what's interesting is this study did not actually only compare carbohydrates to MCTs. They had a third group that ingested both carbohydrates and MCTs. If we look at this table here, it's exactly the same as the one that I showed you previously, now with the addition of the carbohydrates in the MCT group. We see the same steady state lactate concentration up until 120 minutes, where they then began their 40-kilometer time trial. We know that the carbohydrate group saw a rapid increase in glycolysis, but we don't see the same in the carbohydrates and MCT group. We do see an increase in lactate concentrations, but well below any sort of threshold, and it shortly declines after 180 minutes. What's really interesting is that this group was also able to maintain a somewhat steady plasma glucose concentration. If we look at the trend lines of this group, obviously the carbohydrate group had the highest plasma glucose concentrations, and the MCT had the lowest. But the group that was supplementing with carbohydrates and MCTs was able to maintain a steady blood glucose concentration of 5.5 millimoles per liter. And this did result in an improvement in performance. This is only during the 40-kilometer time trial where we see the carbohydrate and MCT group was able to cycle at a higher or faster speed than the other two groups. Similar results can be seen in this study here, which is a more recent study conducted in 2018. Initially, the cyclists had to cycle for 40 minutes at 50% of their VO2 max. They were then asked to cycle at 70% of their max until exhaustion. We can see that the MCT plus carbohydrate group was able to cycle for significantly longer than the carbohydrate only group. So based off this and other research, it's quite clear that carbohydrates plus MCTs seem to work the best. When using this combination of carbs and MCTs, we get an additional fuel source from the MCTs, which potentially spares our muscle glycogen, and the carbohydrates, which help maintain steady blood glucose concentrations. A concern for a lot of runners, particularly ultra runners, is will it cause any sort of GI tract discomfort? Now, when adding any sort of new supplement into the gut, it's normal for it to experience some sort of sensitivity or discomfort. But a lot of the research has shown that gut training can reduce the sensitivity of MCT. I saw this particularly in a group of runners that I worked with testing MCTs. The first time they came into the lab, some of them were quite sensitive to the MCTs in particular, but the second time they came in, the sensitivity was reduced in almost all of them. Additionally, the combination of carbohydrates and MCTs reduces the sensitivity of the gut. We can see this in a few research papers. It's also something that I experienced, and which is convenient because we know that the carbohydrates and the MCT work well in exercise performance. They also seem to have this kind of reduction in sensitivity of the gut. So this is the most effective combination that has been used. Anything higher than this percentage of MCTs has been known to cause more severe gut discomfort, and this 4.3% has proven to be the least amount of discomfort with the most effect or positive effect. So practically, if you wanted to supplement with this type of combination, you would get a water bottle of 150 milliliters, and you would have 10% carbohydrates. That would be 15 grams of glucose powder, or a glucose polymer, which is rapidly absorbed. And then you would have your 4.3% of MCTs. Now, MCTs come in an oil. Here in South Africa, they are commercially available at most of our health and wellness shops, Wellness Warehouse, Clicks, Dis-Chem. You can go and pick those up, and 4.3% of 150 milliliter bolus would be 6 milliliters. You'd want to ingest this every 15 minutes. This has been proven to be the most effective. You're also getting in your 60 grams of carbohydrates. For any runners who potentially respond well to MCTs, if they want to further prepare themselves for races, the first thing that they need to do is ensure that they are training their gut properly, practicing on longer runs, the combination between carbohydrates and MCTs. And if they want to further prep, there has been research which has been effective in, again, combining macronutrients by consuming a high-fat diet for 2 to 4 weeks prior to a race in order to increase fat metabolism. If runners don't enjoy consuming a high-fat diet, fasted training might be preferable to them. This is also very effective in increasing fat metabolism, specifically when they go on longer, low-intensity runs. I would suggest that this is done fasted. Very importantly, though, we want to follow the high-fat diet in order to increase our fat metabolism, but we don't want to lose out on the carbo loading prior to the race. We know how important this is in increasing our muscle glycogen stores. So it's very important to combine both the high-fat diet followed by 2 days of carbo loading prior to a race. This would ensure that we have our high muscle glycogen stores going into the race. A nice tip as well that a lot of runners respond very well to is, instead of doing the carbo loading directly 2 days before the race, if the race is on the Sunday, they could potentially carbo load on the Thursday and the Friday, and then the Saturday can be used for them just to follow their normal standard eating pattern. It's just a little bit more comfortable for some runners, and it can reduce their levels of gut discomfort. We see this study here, which showed the effectiveness of this combination of macronutrients. We have 2 different groups. We have a high-fat diet group and a low-fat diet group. Both of these groups followed either a high-fat diet or a low-fat diet for 2 weeks. They then did 2 days of carbo loading prior to the experimental trial. We see that the high-fat diet group was able to cycle the 20-kilometer time trial at a much faster pace than the low-fat diet group, showing that the high-fat diet paired with carbohydrates worked very well in this group of participants. What's interesting to note as well is that during the experimental trial, both groups were supplemented with a combination of MCTs and carbohydrates, and the high-fat plus carbo loading group seem to respond the best to those carbohydrates and MCT combination. Okay, thank you. That's everything from me. I don't know if there are any questions.
Hi, Dr. Da Costa. That was great. Thank you so much. This is Nadeem. So I had a
Hi,
question.
Nadeem.
Hey, how's it going? So, I mean, I've run a few 24 hours ultras and stuff like that. What do you say to people who fill in those calories lost in a hurry? You know what I'm saying? So, I mean, you're running the races and you're losing X amount of calories, and right after the race is done, we kind of replenish them in a hurry. How healthy is that, or is there more of a paced approach we should take post-race in filling up those lost calories as well, whether it's glycogen, carbohydrates, whatever the case might be?
Well, I think it's definitely up to the runner what they prefer. I haven't done a lot of research in post-running fueling. I know that it's very important, obviously, that we try and make up our muscle glycogen that we've lost. We try and make sure that we get a little bit of protein in as well to fuel any sort of protein damage. And then based off the research with fats, I would try and get like a nice healthy fat in there as well. When it comes to the speed at which you fuel post-race, I don't have much advice. I would personally prefer more of a longer fueling strategy as opposed to just shoving it all in, mainly for gut discomfort and feelings of satiety.
Oh, that's great. Thank you very much. And I guess this is a question.
Sorry, could I just jump in there as well, just to add to what Devon just said, just an extension of what she was saying there. So to some degree, I think, Nadeem, it depends on what you're wanting to do after the race. So if the race in question is kind of the end of the training cycle you've picked for this race, and you're now going into a recovery phase before picking up training again for the next macro cycle, aiming towards the next race, if that is the case, then rapid replenishment is not that important. The runner can just take time out, take a couple of days probably of no running, and then some easy running, and just eating as they feel. it's and by the time they get going with their training again, they'll have replenished their muscle glycogen, and the recovery process will be well on the way. If it's, however, the race in question, part of a mini cycle where there's another race coming up. So let's just say you've run in South Africa, you've run the 2 Oceans Marathon, and then 4 weeks later, you've got to recover in time to run the Comrades. Then it's a different story. You still need a short period, of course, from a training perspective to recover from the first race before resuming training for the second race. And so you do indeed, in theory, want to try and replenish muscle glycogen as quickly as possible, and 2, some protein and stuff will maybe help with protein resynthesis and so on in the muscle. The muscle glycogen, though, trying to get that in as quickly as possible does have problems in that post-race, for a good number of days, the muscle doesn't store glycogen too well anyway. So if you're shoving it down, so to speak, the muscle glycogen resynthesis ain't so good. So my recommendation for that situation is to 1 or 2 days of high-ish carbohydrate content in your ingestion, eating or drinking it, and then to step it up a couple of days later as the muscle recovers and is able to store muscle glycogen.
Oh, that's great, Andrew. Thank you so much for that. And this is just a sidebar discussion post-conference for Matt, yourself, maybe Dr. Costa as well. Is if you guys want to do anything research-wise at our World Championships, you're more than welcome to do, because I think there's a lot of thought process that needs to continue on with these kinds of discussions. So with World Championships, you have this entire pool of elite athletes, and if we can do some sort of a research over there, you guys are more than welcome to do that.
Thanks. We'll take you up on that. Thanks very much. I remember being at the race in the Netherlands when it was at where was that race in? It was the 100K, no, 24-hour World Champs. Back in about Steenbergen. That's right. So yeah, absolutely. We get together at these things and have a bit of a research team there, and we can do all kinds of good stuff.
I would have a question for Mr. Costa. Is there an influence on the on the triglycerides by the omega-3 fatty acids?
Not that I've seen. There was quite an interesting study that I read recently on runners supplementing with MCT, just looking at their, how their levels of triglycerides change, and it didn't seem to have any effect when it was taken acutely. So, like during the running, when you are fueling during the running, you kind of metabolizing it, and there's no sort of effect. But in the study, they did mention that there needs to be more of a look at the chronic supplementation of MCT. So if runners want to take it, for 2 weeks leading up to a race. It's quite interesting because there have only actually been 2 studies to date done chronically on runners, where runners are chronically supplementing with MCT, and it did not respond well in their performance. The carbohydrates way outperformed. But unfortunately, those studies didn't look at the triglyceride levels at all. But it would be an interesting research topic.
Yeah.
What is wichtiger? What's more important to take omega-3 or fatty acid?
What is more important in endurance, to take these MCTs or omega-3 fatty acids?
Definitely the MCTs. They are the rapidly absorbed fatty acids. So the whole reason why carbohydrates are favored during race scenarios is because of their rapid absorption into the muscle cell. Where the medium chain triglycerides, they are absorbed at the same rate as carbohydrates in comparison to your longer chain fatty acids, which require the carnitine shuttle. So that slows down their absorption. So it really is the medium chain triglycerides that seem to have the same absorption rate and then the enhancement in performance. It's because of their chain length. So I don't see the same thing happening with other fatty acids.
Mm-hmm. Okay, thank you.
Cool.
Right, well, thank you, everybody. If there's no more questions, then I will say thank you very much to all of those who attended. Devon, thank you for your presentation. Very nice presentation. I've already sent you a message. And Nadim, we're going to take you up on your idea of getting involved in some of those races, because it's a fantastic research platform. So until next time, then, I wish you all good training, good racing, and we'll see you sometime in the future, another one of these webinars.